Hello students, today in this video we are going to learn about Euclid's division lemma. Before going to learn about Euclid's division lemma, let us see some divisions which you have learned in your primary level. For example, if I take a number 17, which is divided by 3, this 3 goes in 17 5 times, and here we get 15, and on subtraction we will get 2. Similarly, if I take one more example, 16, which is divided by 2, which goes here 8 times, and upon subtraction we will get remainder 0. So you can recall that you have learned in your primary level that these 3 and these 2 are called divisors. Similarly, this 17 and this 16 are called dividends. This 5 and here this is 8 are called quotients. And finally here this 2 and here it is 0 are called remainders. So to check whether our answer is right or wrong, we will follow a simple procedure that 17 is equal to 3 times 17 is equal to 3 times 5 plus 2, and 16 is equal to 2 times 8 plus 0. This is nothing but dividend is equal to divisor into quotient plus r. Here also dividend is equal to divisor into quotient plus r. So from these two examples we can observe that in the first example, the remainder is 2 and the 2 is less than divisor 3. 2 is less than 3. And in the second case, remainder is equal to 0, which is also less than divisor 2. So the remainder is less than divisor. So by this we can understand that remainder is always less than divisor. This is the first thing we noted here. And one more thing is, this remainder can be either equal to 0 or, as we have discussed earlier, it is less than divisor, but this remainder is always greater than 0. By coding all these things, we can write that if we consider any two integers a and B, in which A is greater than B. According to this one, A is equal to B into Q, Q is quotient, plus R. And the condition for R is, it is greater than 0 or equal to 0. It is an inequation. Here we have two conditions. Any one of the condition will satisfy at once. Either this remainder is equal to 0, that means equal, or it is always greater than 0. And this one is less than divisor, here it is B. So Euclid says that when two positive integers are given, suppose they are A and B, then there exist unique integers Q, which is quotient, and R, which is remainder, which satisfies the condition that A is equal to B into Q plus R, where 0 is less than or equal to R less than B. So this is Euclid's division lemma. There are many applications for this Euclid's division lemma. One of them is finding HCF, or simply GCD. I'll take one simple example. To find HCF of 160 using Euclid's division lemma, the process is like this. Let 100 be A and 60 be B. So now we will write 100 is equal to 60 times, if it is 2, this becomes 120, which will be more than 100. So we will take only one time, then it is 60. 100 minus 60 is 40. So we will write remainder as 40. In the next step, the divisor becomes dividend and the remainder becomes divisor. Similarly, here also 40 goes one time and 40 ones are 40. 60 minus 40 is 20. Just like the previous step, this divisor will become dividend and remainder will become now divisor. So 22s are 40. So 40 minus 40 is 0. So there will be nothing left over. So remainder is 0. So finally, when we get this remainder 0, what is the divisor we have in the last step where we get 0 as remainder? That divisor is our required HCF. So HCF of 100 and 60 is 20. Like this, we can solve HCF for two numbers depending upon Euclid's division lemma. There are some other applications on this one which we will see in our next video. So I hope you understand about what is Euclid's division lemma, and this is the very first theorem in our chapter real numbers. So the statement is like this: given two positive integers A and B, then there exist unique integers Q and R which satisfies the condition A is equal to B into Q plus R, where 0 is less than or equal to R less than or equal to B. I hope you understand this one. Thank you.